Hello, let's continue our Sudoku adventure with Dots and Dashes by PjoeterBliep. So this is the final puzzle of our theme week, the theme being Sudoku rules do not apply. So I hope this expanded your mind a little bit. Let's go over the rules to this one. So this is a squishtro quadri. So what we have is we have 4 3x3 boxes in this grid. The cells that have the dotted lines are shared between the adjacent boxes. So this is a 3x3 box. This is the second one, the third one, and the fourth one. Now, within every 3x3 box, we have the digits 1 to 9 exactly once each, just like a 3x3 and a 9x9 Sudoku. And in addition to that, rows and columns do not repeat any digits. But of course, they're not going to have all of 1 through 9 because there's only 5 cells. So in addition to that, so our goal is to place a digit 1 through 9 in each cell such that those constraints are fulfilled. We also have standard crop key pairs. So white dots, digits separated by a white dot, are consecutive. So if this was 2, this could be 1 because 2 is consecutive with 1, or it could be a 3 because 2 is consecutive with 3. Black dots, digits separated by a black dot, have a 1 to 2 ratio, meaning 1 is exactly double the other. So if this was a 2, this could be 1 because 2 is exactly double 1, or this could be 4 because 4 is exactly double 2. So there just needs to be that relationship. The order doesn't matter. Not all dots are necessarily given. That means if there was a 2 and a 4 here, we have not given a black dot there. That's perfectly fine. That solution can still be 2, 4. We have given some of the dots, but not necessarily all of them. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. I think it's going to vastly help my scanning to just color our regions. So I'm just going to do that. So I think the thing that pops out here immediately when we color the regions, so color the 3x3 boxes, is that this middle cell here has all 4 colors. So this middle cell does not repeat in the puzzle. It appears exactly once in our puzzle because it can't repeat in any of the other colors. So I'm noticing this is on a black dot chain. So let's talk about black dots with when you can go 1 to 9. So our low digit, I'm just going to use this as scratch, could be a 1, a 2, a 3, or a 4. Our low digit can't be a 5 because we'd have to double that to 10, which doesn't exist. Now, because it's by definition the low digit, we're saying it's the low digit. To make the pair, we just have to double it. So we double the 1 to a 2, double the 2 to a 4, 6, and 8. So these are our 4 possibilities: a 1, 2, a 2, 4, a 3, 6, or a 4, 8. So every black dot has a 1, 2, 3, or 4 in it, at least one of them. And a 2, 4, 6, 8 in it. So there's always an even number on a black dot, which is sometimes helpful. Especially since there's always at least one even on a black dot. There's always exactly one even on a white dot, and exactly one odd. All right, so you'll notice that 1, 2, 2, 4, 4, 8 kind of chains. You can go 1, 2, 4, 8. So you could have 3 black dots all chained, giving you a 1, 2, 4, 8. But 3, 6 is kind of on its own. You're never going to reach 3, 6 in that group. So there's 2 groups, the 1, 2, 4, 8 group and the 3, 6 group. So what I'm going to argue here is that this can't be the 3, 6 group because we can't repeat 3, 6 that many times in the row. We'd either be 3, 6, 3 or 6, 3, 6, neither of which works. It would repeat a digit. So these are from 1, 2, 4, 8. But we can restrict this further in saying that this middle digit is not a 1 or an 8. It's got to be the 2 or the 4 because we're either going to go 1, 2, 4 or 2, 4, 8, or the other way around, 1, 2, 4 or 2, 4, 8. And so the middle digit's always 2 or 4, and that means that this digit, whatever it is, does not repeat in the puzzle. And I feel like that has big implications on our black dots that are not these ones. Because if whatever this 2, 4 is does not repeat in the puzzle, we definitely can't do a 2, 4 across any of these black dots, meaning they're either 1, 2, 4, 8, or 3, 6. And once one of these black dots is a 1, 2 or a 4, 8, we've eliminated the other one. So 4, 8 eliminates the 1, 2, and 1, 2 eliminates the 4, 8. Now, whatever that one is, so we can have 3, 6s as much as we want, but once we start using a 1, 2, we can't use a 4, 8. Once we start using a 4, 8, we can't use a 1, 2. Otherwise, we'd repeat this 2 or 4. Hopefully that makes sense. Basically, every black dot in the 1, 2, 4, 8 chain has a 2 or a 4 in it, or both. And since we can't repeat them, Anyway, so what I'm seeing here is that one of these has to be 3, 6, and but then the other one is going to be a 1, 2, or 4, 8. Right? We can't ever do 2, 4. If we did 1, 2, and 4, 8, not only would we break this column, but we'd break this cell too, right? And that's the important thing that I'm talking about. And so one of them is 3, 6, and the other one is a 1, 2, or a 4, 8. And that's going to eliminate the 2 and the 4 from here, because we can't ever repeat this one, and this will have the other 2, 4 in it, in one of these black dots. I don't know how to explain that better, so hopefully that's clear. And that means we only have 1, 1, 8 in this black dot chain, so this can't be it. So that's a 2, 4 pair. So this is the other 2, 4. And that's going to require this to be a 3, 6, because this 2, 4 pair is in green already. Green has a 2, 4 pair, so this green, I'm wondering if this coloring is actually helpful. We'll keep it. So that means this black dot has to be 3, 6, because it can't have a 2, 4 pair in it. Can't have a 2 or a 4 in it, because there's a 2, 4 pair. I guess I should talk about these white dots next. So this is an even digit, which means these are going to be odd. 1, 3, or 5. The 2 is going to be with a 1, 3. The 4 is going to be with a 3, 5. But this 3, 6 pair is in green already, so that's not a 3. Let's see. 1 would make 2 here. Oh, interesting. Yeah, okay. So this can't be a 1. Because if it was a 1, then by the white dot, this would be a 2. But within purple, we already have a 1. So this would have to be an 8. And that would make that a 4. So let me just throw it this way. If this is a 1, then this has to be 8. Because purple can't have another 1. And now the 1 wants this to be a 2, and the 8 wants this to be a 4. That's a contradiction. That doesn't work. So this has to be 5, and that makes this a 4, and that makes this a 3. 4 makes this a 2. And this could be 1 or 8. All right. 3 would be with a 2 or a 4, but 4, again, 4, we now know that 4 does not repeat in this puzzle. So this has to be 2. And we can't do 2, 4, so we got to do 2, 1, and that makes that an 8. And we know this is a 3, 6 now. 3, 6 pair. Okay. Do we want to think about what's next to... Oh, okay. Actually, over here is better. This can't be a 3, because if it was a 3, this would be 2 or 4, but 2, 4 is gone in green. So this has to be 6, and this is 3, and that makes this 3 and 6. So now this has to be the 2, because 4 does not repeat in the puzzle. All right. So this is with a 5 or a 7. Oh, there's already a 5 in green, so that's with a 7. So there's a triple left in green. What is it? It's a 1. We have 2, 3, 4, 5, 6, 7. 1, 8, 9. Now, purple already has an 8. Green needs an 8, so the 8's there. Because the 8 repeats in the row here. All right. 1 or 9. Interesting. So now purple has a triple left. We need a 1, 7, 9. Is there anything? Yeah, this 1 sees here. This is a 1, 9 pair. I don't know if I can... It's a little interesting. It means that's not a 9. Let me explain. This is a 1, 9 pair because of green. And this cell here sees this one through orange, and it sees this one through the column. So this 1, 9 pair will include a 1 and a 9, and it eliminates 1 and 9 from here. Oh, actually, you know what? It also eliminates from here, and that's actually helpful. This is a 1, 9 pair. This can't be a 9, because it would make both of these 1, which would repeat 1 in green. So that's a 7. And now this is a 1, 9 pair, for what it's worth. So that means these are the same digit. Okay, there's probably something simpler to do here. Oh, right. So where's 1 in orange? This can't have a 1 on it because it would be a 1, 2, and there's already a 2 in orange. And so this is our 1, and that makes that 9 and that 1. All right, so the top's totally done. Let's think about what blue needs, I guess. We have 1, 2, 3, 4. We need 5, 6, 9. This can't be 5 or 9. So this is our 6. I think this can be just 5, 9 pair. Do we want to think of the white dot? Let's think about what's left. Let's just fill out what's left. We have 1, 2, 3, 4. We need 5, 7, 8, 9. So we know that's not 7 or 8, but that's not 7 or 8. So then these aren't 5, 9. So that's a 5, 9 pair. That doesn't help. I must be missing something here. Maybe, oh, 5 just doesn't work with this dot here. Oh, this, okay, here's a, we can use the even odd argument. This is odd, making this have to be even. It can't be 6, so it's 8. That's 7. 8 has to go with 9, not 5. That's 5, and that's 5, and that's 9. All right, we're done. Okay, cool puzzle, Peter Bleep. I don't know if the coloring helped or not, but I guess it didn't hurt too much. Cool. That was a neat puzzle. I enjoyed that solve. I liked the idea of utilizing the fact that the middle cell doesn't repeat anywhere, and then restricting a 2 or a 4 out of all the rest of the black dots in the puzzle was a neat mechanic. I also liked this little chain here where this couldn't have been a 1. That's an interesting interaction. All right, cool. Well, let me know how you did, and if you enjoyed this, want to leave a like, subscribe, and a kind comment below.